Hi Mom, welcome back to Learning Physics with me. Today is all about momentum, collisions, and center of mass. First, we need to understand momentum. The formula for momentum is mass times velocity. Momentum is easier to see than it is to explain. Imagine a donut on top of a hill, and as it rolls down that hill, it carries momentum. But since that donut doesn't have very much mass, it doesn't carry very much momentum. Now imagine that there's a boulder sitting on top of a hill. Now this boulder weighs about a ton. Now if the boulder rolls down the hill, it carries much more momentum than that donut did because it has more mass. Next are collisions. There are two types of collisions, elastic and inelastic. First, I'll describe an inelastic collision. This is when two objects collide and stick together. Next is the elastic collision. This is when two objects collide and bounce off of each other in opposite directions. There is one important thing to note about collisions. The total momentum before the collision has to equal the total momentum after the collision. Also, kinetic energy is lost during a sticking collision, but it is not lost during an elastic collision. And finally, we have center of mass. Center of mass can be thought of as an imaginary particle that perfectly balances two objects. If two objects were attached by a stick that had the same exact mass, the center of mass would be directly in the middle. But think of the hammer. If you throw a hammer, the center of mass is much closer to the head of that hammer, so it would give it a weird rotation. That's because the center of mass is a lot closer to the top. Now I'm going to show you an experiment that I did on Tracker to understand momentum. The experiment that I did was an elastic collision. I pushed these two cars against each other and the magnet repelled them in opposite directions. You can see the graph to the right shows their position versus their time. This is the graph that Tracker came up with for the total momentum of the collision. Here in the middle where the two paths cross, that's where the collision occurred. The red represents the red car and the bluish green represents the blue car. You can see that they actually swap momentums. That's the total momentum of the crash, or the total momentum before the crash and the total momentum after the crash being about equal. The reason they aren't exactly equal, there are other forces here on Earth like gravity and friction, but you can see the concept that the total momentum before the collision equals total momentum after the collision. Now we can take a look at the code. We just recreated the situation with the cars using this code. Up top here is just making the boxes that will be colliding together, give them velocity and mass. Down here is what we're worried about. This is the meat and potatoes. Up here, dt is the change in time like last week that we talked about. That's going to be used in the calculation. The dx 1 and 2, that's showing the velocity. That's where how we're making these boxes move. And we use the velocities up top. And the center of mass, this is the formula for it, and this is it's showing the center of mass between the two boxes as they collide and then separate. Down here, this is the while loop. So this is the most important part of the code. So while this is not collided, we want the dt and the velocities to continue until they do collide, and that will make this not true. It'll make it false once they do collide, and once they collide, we will get some information from it. And this is what is defined as collided. It's the distance of these boxes together divided by 2, which is just showing the center of one box to the edge of it and the center of the other box to its edge, because they are both the same size. So once the computer recognizes that this distance has been met, that the computer knows that it has indeed collided. So we'll run it here and I'll show you what I'm talking about. See the center of this box and the center of that box, once it recognizes that distance has happened, then it knows that it has collided. And after the collision, we want it to print that it has detected a collision. And after the collision, there's new velocities, and that's what this next line of code is showing here. Remember when I said after an elastic collision, they essentially swap velocities, and they go on the opposite direction. So that's what this is showing. We're telling the computer v1 equals this new v1 new, and these are the new velocities that I want it to travel at. And then we're going to tell the computer to print them so I know what they are, what the computer is calculating, and also the kinetic energy as well. And this is the formula for kinetic energy. Kinetic energy is 1/2 mass times velocity squared. And here it will print after the collision its new kinetic energy. So there you have it. Now you know a little bit more about momentum, collisions, and center of mass. One important thing to note about the experiment, the video doesn't quite exactly match up with the computer simulation. That's because, like I said earlier, there's other forces here on Earth like drag, gravity, and friction. In the computer simulation, there was none of that. It's like the collision was happening in the vacuum of space. So that's why the numbers didn't exactly match in the computer simulation and in the video. But that's okay, because the numbers were barely off. My main goal was to get across momentum and what it is. So I hope you learned something new. Thanks for watching.